continuously, the output voltage will either be zero, will definitely be zero. So the action of opening and closing with some duty cycle of ratio of on to off time, we will be able to control the output voltage somewhere between the input voltage.
Check, 1, 2.
But of course, we really only want to hold the output voltage constant, but the same action takes place to accommodate variations in input voltage or load current demand. And we control that by means of the schematic shown in the lower left-hand corner, where we're sensing the output voltage and using that to generate a pulse width modulation command. And that establishes the on to off ratio, which is defined as the duty cycle. And as you can see from the upper equation on the left-hand side, the overall gain of this power stage is that the output is going to be equal to the input times the duty cycle. Now the question then comes up, well, how do we generate this variable pulse width modulation? And here's the circuitry it takes to do that. You can see, first of all, that we're going to sense the output voltage. We do that by a feedback signal that comes in from the left-hand side of that block diagram from sensing the output voltage. And we're going to compare that to a reference voltage, which is a fixed voltage. And the difference between those two will generate an analog error command that will identify how much energy we need to maintain the regulated output voltage, which means drive the feedback signal down to where it equals the voltage on the reference. And we do that. Well, the second thing that this circuit has is a timing function which needs an oscillator, and we have an oscillator there that is designed to provide a fixed frequency, a steady state fixed frequency that sets the switching speed, the switching frequency of the overall regulator. But it does another function in this circuit as well, because it also generates a sawtooth ramp waveform, which is shown in red in the waveforms down in the lower portion of this picture. The logic is set up by a PWM comparator, which compares this ramp voltage waveform to the voltage out of the error amplifier, which is essentially telling how much energy is needed to maintain. There's this ramp voltage waveform to the voltage. And if we look at that signal, we've shown it in the waveforms as a green line, which, if not much energy is required, will be fairly low.
Zero. Will definitely be zero. So the action of opening and closing with some duty cycle of ratio of on to off time, we will be able to control the output voltage somewhere between the input voltage.
Check, 1, 2.
That output pulse, which is triggered by the ramp waveform being